I'm pretty interested in what we're going to hear today, because I think we're starting to get to the front edge of machine learning and sensing that can actually give us some good quality information, which has probably been hard to make good quality actionable decisions from sensor data in the past, and we're starting to get to a point where we can make better decisions than what a farmer can make on his own. So today, everybody, we've got James Raby, who's the Chief Operating Officer of Fluorosat. Fluorosat is an Australian tech startup company that are working in this sensor and machine learning space, and looking at different ways of solving problems for farmers on farm, and making, delivering accurate and actionable information for farmers and crop agronomists in their crop requirements. James has come from a background of marketing, software development, and he's worked in Europe, North America, and Asia, and he's been with Fluorosat for about 2 years now. So welcome, James, and we're really excited to hear what you've got to say today.
Great, thanks, Tim, and good morning, everybody, as well. I should also add that despite being an engineer and marketer, I'm from the central west of New South Wales, grew up on an orchard, did ag science until year 10, and then was convinced to focus on maths for an engineering career. Finding out later it was because I annoyed the entire agriculture science faculty at high school, just with my incessant talking and interjections. So as also Tim mentioned, the idea of this presentation, I've only got 20 slides. A lot of them are quite visible or visual, but it's also meant to be interactive. So rather than waiting till the end of the session to ask a question, feel free to interrupt and ask the question. And as much as possible in this webinar format, discussion is often as useful as just listening to someone like me speak as well. What we're going to cover is I'll give you a quick introduction to Fluorosat and the Fluorosense platform. I'll take you back a little bit to explain multispectral data. I think a lot of people attending this webinar would be aware or had some experience with NDVI. I'm going to sort of go back and just explain why we use that and what its limitations are as well. And then I'm going to take you through the sort of the useful uses, if I can put it that way, of the platform. Primarily around monitoring the performance of crops, being able to do nitrogen prescription at tillering based on estimated yield, being able to assess the extent of frost damage in a paddock, being able to identify potential pest and weed detection. And then also because a lot of the people dialing in today are dealing with issues of scale. I mean, the sort of the 500 to 600 hectare average farm 20 or 30 years ago is small nowadays, and you're dealing with thousands of hectares, often farms that are sort of kilometres apart. So also just understanding, where to look, which paddocks to look at and where in which paddocks to look at as well. I've got a separate section for questions as well at the end. So for any that we don't pick up during the session, we'll take up then. And then also for anybody that's interested in having a look at Fluorosense, I'll give you information on that. So a little bit about us, just carrying on from what Tim said without repeating anything. We're about 3 years old. We've got just over 20 people across Australia, US, and a little bit in Europe, but we are an Australian company with offices in Sydney and Canberra. We've got a group of engineers, but we've also got people like Dr. Ben Jones, our head of science, people with PhDs in agricultural science and agronomy, backed up with people who've got experience with remote sensing and machine learning and artificial intelligence. About 18 months ago, we were given seed investing seed investment from Main Sequence Ventures and Airtree. So Main Sequence is CSIRO's venture capital fund, and Airtree you may have heard of, which was founded by a ex-Microsoft executive who's Australian. Is well known for investing in startups as well. So since that investment, we've grown the number of hectares that we monitor in Australia and the Americas up to over 1 million hectares. We've also, through the acquisition of production-wise from grain growers, we've been able to incorporate AppSim into some of our models. And we've also, for cotton growers, been able to incorporate the Nutralogic or COT Assist algorithms as well into our models. And then look, during that period as well, we've worked on a number of RDC and government research projects and continue doing that, looking at things like plant available water, nitrogen, of course, and other objectives that are relevant to agriculture. So all this work goes into our vision, and the vision is that we can start to tie together all of these different tabs, if I can put it that way. So if you think about, your browser, and you'll have your farm operations data, you might have like My John Deere up looking at your yield. You'll be looking at sort of something like NDVI, and you're trying to make sense, but it's all sort of sitting in different silos, in different tabs of your browser. None of it's really trued up to each other. So you sort of, first of all, trying to scrub the data and then true it against something else. So, a good example of that is, comparing a yield file to what's actually has happened in the paddock during that season as well. So what we do is we start with the multispectral data, either from satellite or drone, or fixed wing as well. Then we add context to it, with elevation and pH and yield maps. Where necessary, we true it up with samples from the paddock. And it was also, we make it a little bit more sensible by saying this crop is X number of weeks since planting, and this crop has just had a nitrogen application. So that when you're looking at the data, you also understand the context within the season that you're looking at that. We also take in climatics, understand the rainfall and the growing day degrees based on what the temp's been, and then we apply some of those models. So we're bringing that all together, and our objective is that for any of our customers, it's not another application you have to jump in, yet another tab on the browser. What it is instead is something that sits in the background like an engine. So look, if you're using SST or AgWorld or BackPaddock, production-wise or whatever, you're able to just send that information to our engine, and what comes back is something in your own system to then go and implement. Try and move or remove some of this cutting and pasting, which is a bit of a bane to digital ag, and make it all happen in the background. However, we're sort of still some way from that vision, or the industry is some way from that vision. So what we've provided is a really good user interface. And what I mean by good is that we've made it easy to use. We've removed as much clunkiness as possible, and it's easy then to take the insights you get from fluorescence and put them into action. So let's talk about crop remote sensing when used in ag specifically, right? So what we do is we take a number of visible and non-visible spectral bands, and we use them to measure how much of each pixel, and a pixel is, if you know the pixels on your screen, the pixel is what the smallest unit each sensor can pick up. So from a satellite, each pixel is about 10 square metres. A plane can pick up down to centimetres, and drones flown at 20 metres above the crop can get down to millimetres as well. So what we do is we look at each one of those pixels and we go, how much of that is healthy and how much of that is soil and how much that's unhealthy. And we can do that because vegetation responds to each of those different spectral bands differently. Healthy plants absorb red. They reflect near infrared. Chlorophyll reflects the red edge band more than it does red as well. So what we can do is if we measure the reflectance, so think of it almost like a radar or an X-ray bouncing back, what we can do is get a fair idea of every one of those pixels. How much healthy biomass is there? How much photosynthetic activity is there? And therefore, how much nitrogen is there as well?
Is there a time and place where it's better to go satellite versus fixed wing versus drone, or is there, are there different products that sort of suit different monitoring techniques?
Yeah, really good question, Tim. So absolutely. Look, the benefit of satellite is that it's regular and it's also economic. However, satellites suffer from the effects of cloud, and I wish we had more cloud this season than what we're getting. But certainly the spectral bands that are used to create these indices are massively impacted by cloud. So that's where fixed-wing aircraft and drone come in primarily, is to get in under that cloud during those key periods. So if you've got a long period of cloud leading up to, say, tillering in grain, being able to get something closer to the ground is going to give you more up-to-date information as well. Also, and I don't know how many people here are also in Hort, but being able to get closer to, for example, grapevines to look for downy mildew, for example, requires a level of accuracy that you probably only get from a drone.
Yeah, right. Well, so when we were talking that, so the frost and the insect damage and things like that before, can you do that with a fixed wing or a satellite, or is that more a drone thing?
You can definitely do it with satellite. And I've got some really good examples here, but often what you've got to look for isn't the actual cause, but first of all, the effect. So, I think ultimately, Tim and I were talking before this webinar, talking about, what we've seen in 20 years. And I think in 20 years, there will be sort of applications and technology that say, okay, you've got lucerne fleet, right? We'll be able to recognise what's going on just by the pattern of response in the crop. But, the most practical thing we can do nowadays is to look at a crop in a paddock and go, there's an anomaly in this area. There's an area that's not performing the way it should be. And then start to identify the patterns of that. Obviously, you get rid of the permanent effects, like a change of soil type, or just even an area that's got a few trees in the paddock that is obviously going to be a lower performing. To look at what's changed, what shouldn't be there. And that can also apply to areas that are performing too well. So, for example, obviously, if you're in a fallow paddock, seeing vegetation grow probably means you've got weeds or volunteer crop. So it's being able to, first of all, identify those patterns or those poor performing areas. And in the majority of cases, you can do that with satellite. The other point I'd make as well is that with satellite, you get 10 square metres, which compared to a drone is massive. But, how many people can practically change the rate of application within a square centimetre? So, that's where, satellite still comes across very powerful. But, fixed wing and drone also give you, more of a variation in smaller areas. So if you're really pinpointing something, that's where it becomes useful. Hopefully that answers the question, Tim.
Yep, no, that's good. Thanks, James.
Good stuff. And then, look, we just talked about, when would you use plane versus drone versus a satellite? But there's a number of different indices, and they're also useful, probably more looking for different things at different times of the crop. I think anybody that's used multispectral data is used to NDVI, the Normalised Differentiated Vegetation Index, for short, and that is, measuring how much vegetation biomass is in the crop. That's really useful for, checking a well-grown crop up to the point that you've got full canopy cover. It's not very useful early stage because, the way that NDVI works is it is easily interfered by soil. So if you've got sort of, a crop that's just emerged through to probably mid or late tillering, you've got a lot of soil still visible, and that's sort of almost blinding out the level of detail. I've got some good examples out of that. So there's an index called MSAVI, which identifies and removes the soil. So it takes away that interference. So just think about sort of like, for those of us who are old enough to remember when you had to tune TVs, tuning the channel or the radio, getting rid of that sort of noise until you've got a clear signal. But then there's a couple of other indices as well. NDRE, instead of using red, uses the red edge. And what that does is measures how much chlorophyll is in the paddock. And because chlorophyll is at least 80% nitrogen, gives you an idea of what's the nitrogen uptake in the crop. And that obviously leads on to being able to determine how much nitrogen you need to apply to finish through with the season. So there's one final indice I'll talk about, which is CCCI, which basically just takes a proportion of that nitrogen that we've picked up with NDRE, divides it by the biomass that we see, in order to get an idea of how much nitrogen there is per plant. So that, you're not just looking at a high, nitrogen part of the paddock because there's high biomass. You're looking at the health of individual plants as well. Okay, so that's remote sensing data, but how do you actually make it both useful, right, so that you're not spending time trying to make sense of what you're seeing before being able to get insights, and how do you make it usable? How do you take those insights and put them into action? So you need to give context to that data. I mean, I can show you very similar looking multispectral maps, like an NDVI map, of two completely different crops at two completely different stages, and they look exactly the same. So how do you interpret that? So first of all, you apply the crop information. What was planted, when it was planted. You then add in any operations that may impact what you're seeing there. Has it been recently fertilised? Has it been flushed if it's irrigated? Also, one of the most common things that you see in an NDVI map, for example, is the difference in soil layers. So you might sort of see something that looks radically different, but that's because it's a different soil type. It's, sandy or sodic or more clay in that part of the paddock as well. What's the condition? I mean, this is where sort of EC maps become very useful as well. And, what's varying in the paddock? And then obviously having a look at what's happened with the weather. If you've had high rainfall, you had, sort of good sort of, long daytime warm hours, so you've got your growing day degrees increasing. You want to be able to tie that back to what you're seeing in the imagery as well, so that you understand that when you're looking at something that you should be expecting to increase, it has increased at the rate that it should have.
So how are you tying those soil layers in there, James? Because, I mean, that's a massive data layer, and to try and bring that in there and understand the implications on productivity, is that a little bit of APSIM data as a foundation?
So the APS Soil database, which is part of the APSIM platform, is something that we use. That gives you a good understanding of the soil types per district. We've also got some clever ways that we can determine soil variation within the crop. One of them is actually look at almost like a bare image, like an RGB photograph of the field in fallow, to be able to determine different soil variations or just even the current soil type. And we can also observe the previous season and have a look at how the crops responded. So we use all those three bits of information to infer what the soil type is. Now that's pretty accurate, but it's certainly not 100% accurate. So being able to get a soil map, that could be an EC map as well. We actually import those layers in. And then the more information we've got, the more confidence we've got in our models, because we can use that information so that, we can have a look at the pH, for example, in a pH map, and take that in consideration when we're generating a model. So the idea is to make it as easy as possible and to encourage, make it, I guess, more people to be more encouraged to import this data, because if you put in a yield map, put in an EC map or a pH map, you're actually getting better data out. And that's a big part of our objective, is by making it easy to put this information in, make the payback quick and easy, people are going to be encouraged to do it more.
Is it more what we're going to learn in 5 or 10 years' time from some of that stuff if we keep putting this information in and then cross-referencing it with yield data and other points that'll start to become powerful?
I think it's going to be sooner than that. And, it's not because I'm unrealistic. It's because if I look at what I've seen over the past year, and not just what we've been doing, with what I see in the industry, I think while this whole idea of sort of spatial data and precision ag still feels a bit embryonic, even though it's 20 years old, just the changes that I've seen across the industry, people sort of learning approaches, obviously machine learning being a lot easier to implement, is taking away a lot of that crunching that made it really difficult to get a map in the first place, let alone analyse it. So a lot of that, I've seen, look, I've been in the tech industry for 30 years, so I'm seeing a similar sort of theme and trend to what I saw in just PCs going into offices back in the late 1980s when I started working. A lot of that sort of number crunching is being automated for us, and allowing us to kind of go up another level. So look, I think I'm pretty confident that in the next couple of years, we're going to see a massive shift in being able to bring all that information together. Just as a side note, Pluralsight, with a number of other organisations in Australia, including CSIRO, PCT, and AgWorld, have got a Commonwealth Government grant for a 3-year project to develop a standard way of interchanging agronomic information. So I think those sort of projects, the idea is that we don't deliver that or everything at the end of year 3, that we start to deliver that to the industry, within that 3-year project. That's going to make it a lot easier as well. Because, if we can start to work with standard ways of treating this data, then we can stop having to munge and scrub the data and start focusing on how do we pull this all together to give something more meaningful.
Yep. No, that's great. That's good to hear.
Yeah. So look, once you've got that info, what do you do with it? Do you put it into a machine? So that's been one of the other challenges as well, is taking the analysis that you get from remote sensing and other data and being able to get it into the tractor as quickly and easily as possible. And that, Tim, is one of those areas where I'm seeing a lot of movement in the industry, where even a year ago, getting something from a shape file, which is something that the spatial application sort of exports into my John Deere, was quite difficult, and vice versa. Getting yield data out, I think anybody dialed into this webinar that deals with yield data will know how difficult it is to kind of scrub it, calibrate it, and make sure that you've got just one paddock. A lot of that's being automated, making it a lot easier and therefore a lot more streamlined to get this data in and out as well. But, I think we in the industry tend to focus on the edge cases of being able to just develop an analysis and a recommendation, export it straight into a tractor or other equipment and let the grower go for it. But sometimes just giving a contractor a map and saying, go and do this particular task in this particular area. Most people have got GPSs on their phone, so just even having a simple sort of map that can kind of direct them to go and do what they need to do is a way of making this information useful today. Good stuff. So the customers that we've got typically use us for 4 separate things. Overall, just monitoring the performance during the season. Having a look at the paddock and going, is the whole paddock growing the way it should be? Is there an area in the paddock that isn't? Key one, of course, is nitrogen fertilisation in crop. How early can you actually get a good picture of nitrogen in the crop, and where in the crop you need to apply what rates? You're trying to avoid overcooking and undercooking as well. A lot of the customers I speak to, ones that are actually quite advanced in digital agronomy, they'll tend to put more nitrogen in the parts of the crop that get the better yield. And they kind of know that it's not the right approach to take, but it's one that they've been doing for years and one that they're comfortable with. And so what they're looking for is a better understanding of where to put it to get the lift of yield more consistently across the crop. And then frost. I mean, that's quite an emotional decision if you've been hit with frost. And as I mentioned before, I grew up in the Central Western Tablelands Orange. Frost is something that we have every day, even Christmas Day. But for those of you in grain crops, particularly with crops maturing earlier now, the sort of post-head emergence frost damage appears to be increasing. I mean, if I look at reports, and there's not a lot of real quantification, but the GRDC themselves estimate, I think, that it costs the industry around about 240 million a year. And other research by CSIRO say that the incidence of frost isn't necessarily increasing, but the incidence of frost that can actually damage a crop is increasing because of that sort of early maturing that we're seeing as well. And the one that we touched on before when we were talking about sort of drone data is also looking at what's stressing the crop, whether it be sort of weeds, pests, or a disease. Looking for those areas of stress, and then going and ground truthing that and finding out what is causing the stress. So I'll give you an example here of monitoring this season. What you're looking at here is an MS AVI map of a paddock just at planting. Looks pretty red, means that there's not a lot happening there, it's just mostly soil. We flip ahead a month, and what we can see is the crop emerging. If you can see my mouse, we're starting to see some patterns there, that there are certain areas that are not doing as well as others. Just by the way, if you can sort of see almost this straight line there, that, interestingly enough, is a control strip where they didn't apply fungicide at planting. So that that sort of weak area there is a pretty quick indication, because that's 6 or 7 weeks after planting, that it's not coming out that well. Okay, now we get to sort of like mid to late tillering period here in this barley crop. And what we can see here is that the greens and blues are saying that we've got really good biomass across the crop. Those blue areas in particular are high, and then those lighter sort of green areas are a little bit low, sort of, and you kind of still see that almost pinky patch there, that control strip. So speaking of trials, the grower here did a couple of things. First of all, I mentioned that he's one of those guys that actually tends to apply more nitrogen in the areas that he gets the higher yield. And you can see that this application map here, when the average was probably about 80 kilos, I think he's put about 100 kilos there. And then just to test a couple of theories that he had, one was to actually see that if he really overcooked it and put 150 kilos on this strip, what kind of response would he get in yield? And also, how quickly could we monitor that response as well? So the interesting thing is, if you then go to NDRE, where we're sort of monitoring the nitrogen response, look at how in particular that strip, how quickly, and we're talking about 5 weeks later, but how quickly we see that response there and how clearly we see that response there in the nitrogen there, in that really obviously heavily applied strip, but also up in this area here, where he applied 10 to 20 kilos more than normal.
Were you picking it up any quicker than 5 weeks, James, or does that seem to be the level that it come in?
The only reason that we didn't is that we had 4 weeks of cloud between the application. So we definitely didn't pick up anything a week after, because that's the last map that we had. So given how strong the response is there, we suspect we would have picked it up quicker. Right? Unfortunately, I hate to say that with those 4 weeks of cloud, I think he got no more than sort of 15 mil of rain. So, and then if I switch together another 5 weeks or so, what we see quite clearly now is the response in biomass. So I'm going to step back a sec, and I'm going to say this map is showing us the nitrogen response, right? So at this particular point, we weren't seeing much of a difference in the biomass. However, if you switch another 5 weeks later, actually probably a little bit more, another sort of, 6 weeks later, you can see the strong response there to those heavier applications in biomass. Whether it was to do with the drought or just the fact that he probably overcooked it, he didn't see much of a response in the yield. And what I'll do is I'll switch straight over to the yield data there. And what you can see there is, definitely, and I should explain this map, anything deep red is less than half a tonne. Anything in the blues is 3 to 4 tonne. And you can kind of see there where he had that control strip, certainly got a reasonably good yield compared to other areas. But this is, I guess, a good example of showing how yield data can help us sort of better understand what we're doing and how that works. What you can see is that control strip I mentioned ended up yielding pretty poorly. What we saw here, funny enough, was where he was putting in the 90 kilo rate, really didn't get that much of a better response. And where he actually applied the normal rate, he got a reasonably good response as well.
So has he got any soil data that he was using underneath that, or is that just he just runs off NDVI maps?
No, he certainly does. He sees some of his maps as well. So that if we flip back to that application map, some of that is informed by soil type. And he's had this particular paddock for 30 years as well.
It's the old thing about nitrogen. Mother Nature still has the last say, doesn't she?
That's absolutely right. Still need water. And then all I'm just showing you there is just how we've picked up when that crop's been harvested. So how do we make that useful? Well, what we do is we time tissue sampling in the paddock with either, in this case, you're looking at drone data, so you can see the higher resolution. What we do is we take directed tissue samples in parts of the paddock where we're seeing a variance, and we do it at the same time that we fly a drone. We've been doing that for a couple of years now, and by being able to do that, what we do is we tie the nitrate percentage from those tissue samples with each of those CCCI values that I mentioned, and we're able to, having done that hundreds of times across scores of paddocks, build up a model that then extrapolates those values across the paddock to give you a clear nitrogen map. We've been able to prove that model in grain. And then by being able to do that, we were able to now use that as a proxy for tissue sampling. So, look, it may be different for some of you, but the typical approach that I hear with commodity crop growers that are taking tissue samples is you take soil type in consideration. Some people will take NDVI into consideration, and you'll go and look for average areas in the paddock. And you'll take composite samples and you'll use that as an average. You'll definitely get a very good, accurate per plant nutrient content, but because you're averaging it, you're not getting a good across paddock variation. By doing this, by proxying remote sensing for tissue sampling, you're effectively getting a sample across the entire paddock so that we can have a look at those variances and we can actually adjust our models accordingly. And this is where we start to tie in some of that other information. So we're taking that nitrogen map, which now doesn't require tissue sampling to be accurate enough. We're taking current biomass into consideration. We're also going back and having a look at the fallow period of that paddock and looking for the weed effect. We're also calculating the growth stage, but we're also taking into consideration any nitrogen that's supplied by the grower. So this is where it's important to be able to add in an application map. We're able to take weather and we're able to apply APSIM in order to create a very simple version of APSIM that allows you to create a variable fixed rate application based on all of those data points and models, but also your own economic circumstances as well. So the model will change if the grain price goes up, it'll change if the urea price goes up as well. So those two areas there, you can set that. You can actually set a gut feel about how do you think the season's going to end. So, what we've got here is a slider that gives you dry through to wet. But what that is not for the entire season, it's from this point onwards. Because we've got weather data, so we know how much rainfall we've had up to now. What this does is say, right, so, based on neutral being, the season's probably going to end the way that we expect. Wet means that, maybe there's going to be 15% more rain. And same as with dry, 15% less dry. You can actually then adjust the model based on that rainfall. Going back to what we said, that you've got to rely on Mother Nature to see it through. We can make those adjustments in the model. You can also adjust it based on what ROI that you want from your nitrogen input. And so the idea there is that, depending on what your risk aversion is, you may be the one that wants to spend $1 to make an extra $1, but you might be the one that wants to save a penny to save a penny. So being able to change a risk profile and being able to adjust what we recommend based on that moves it away from just science and also gives the grower a bit more of an input with the agronomist on what they want to see.
And that's as much about every nitrogen decision that's ever been made, really. There's a lot of risk factors that go into it. It always surprised me when I was out talking to farmers. You'd go to one farmer, you'd have the exact same conversation, and the difference in what they decide to do, like my fuel on the year hadn't changed, neighbouring properties, and one of them would be doing nothing and the other one would be doing 100 kilos to the hectare every time. And it's their attitude to risk and where they think things are going. So you've got to be able to factor that into a decision.
That's right. And if farms like a business, every business has different circumstances, different financial models. So it's taking that into consideration as well. And look, as you can see here, particularly for those that you have used Yield Profit or APSIM, what we've done is we've simplified it. We've still a fair bit of confidence in the model, the more information that we put in. So I mentioned before what we do with the AppSoil database and how we also validate that with what we can tell in the data, helps us then be able to create an accurate model for what you need to apply, where you need to apply as well. And then that can get exported straight into a variable rate application map into CNH or My John Deere as well. So why do it? As one grower put it to me, what they want to do is they want to get the best economic output from the paddock. Obviously conditional to how much rainfall they're getting. And it's for them, it's also being able to know where they need to put up nitrogen and when as well. You're going to get people in the industry like me saying, look, you can lift yields by X%. But in the trials that we've done over the last couple of years, realistically, lifting it by, sort of 300 kilos to half a tonne is normal, right? we know that and it isn't just about fluorescence; it is about right applying nitrogen rather than flat applying. You know that if rather than overcooking the areas that already have sufficient and undercooking the areas that don't get enough, being able to base your application on need of the crop at that point means that you can lift the yields to be more consistent. So your worst performing areas are performing more closer to your best performing areas. And obviously there are factors in there that you can't control, like soil type, like elevation, for example, and other factors. But being able to just focus your efforts rather than just on those areas that are already performing and you're not going to get more than 4.5 tonne out of it. For those areas that are probably only doing 2 tonne and you can actually squeeze another 0.5 tonne out of there, you're going to get a better performance from each paddock as well. And one thing I want to make clear as well, I'm showing you variable rate, but even doing a flat rate based on what the crop needs rather than what you think is still going to give you an ROI, because you're either not applying as much as you would, or you're applying a bit more and you're actually seeing the yield potential grow up because you're applying more than what you felt that you should as well. The next use that people are very interested in, particularly in the southern regions of the country, is frost detection. So I think I was speaking to Tim before the webinar started, so most of you probably didn't hear, but what our frost analysis came out of was we were actually doing trials on nitrogen detection. So we were actually running trials in South Australia, determining how early could we accurately detect the nitrogen content and how closely would that then be correlated with yield. And we had a few paddocks that were frosted, which completely messed up our analysis. So the data was pretty useless to us because, sort of half the paddock had been frosted. So therefore, the readings that we were taking at sort of early tillering, obviously the crop didn't yield anything, so we weren't able to do that correlation. But as we were looking at it with the customer and the agronomist, what we realised, or to be honest with you, what they realised was there's something more powerful. That in our analysis, when we looked at the frost event and we looked at the data in the next 5 days after the frost event, we were able to quite clearly see the areas that ended up resulting in a poor yield. So we've then been able to look at a bunch of other paddocks across the country and develop some models that allow us to detect the extent of the frost damage for post-head emergence crops. We're now focusing on stem frost because we definitely see some patterns in stem frost. One of the things that I've noticed, by the way, is in looking at some of these frosted paddocks over the last couple of years, I've been provided with the data, is that I observe a cumulative effect. So that, I think, for a lot of people, it's the last frost, the one that you act on. But, that frost happens a few times during the season. And what I see in the performance of the crop is areas that get frosted early while it's still in the stem. It still does recover because you're getting a bit of rainfall or for whatever reason. But that part of the crop never really recovers like the rest of it. And then because of the way that frost affects low-lying parts of the crop, the whole area, including that area, gets frosted. So that's the decision you make. But definitely I'm looking at some really interesting data that sort of says that we can see the impact on yield from an area that was stem frosted but not so.
How early in the year are we starting to see that cumulative effect come in? Like if we're seeing it at tillering, is it causing an issue later on, or is it just after stem elongation? Because, if we're getting crops that are frosted early in the year and we're seeing a flow-on effect to yield, then do we need to, and obviously a lot more work needs to be done here.
Yeah.
It's a great JRDC project in it by the sounds of it. But, do we need to start counting that in our estimations on yield, saying, well, we got frosted at tillering in a big way. Maybe we just say, instead of thinking this crop can do 3 tonne of the hectare, maybe we just need to factor that into our nitrogen decisions?
Yeah, so look, answer that question is there is definitely still a lot of work to be done there. We're sort of starting with post-head emergence because that's obviously when you're often making that sort of cut versus harvest decision. But to answer your question of how early we're seeing it quite clearly at booting, seeing it relatively clearly right back to probably mid to late tillering.
Yep.
It's basically from the point that we can use NDRE because what I've noticed, and I'll keep on sort of reminding everybody here, I'm an engineer, not an agronomist, but from my engineering perspective and from the scientists that I work with, what we see with frost damage is, first of all, a cessation of or a pausing of photosynthesis, right? So we see chlorophyll flatline, doesn't drop at booting. It just sort of stays the same for a bit before it picks up again. So we see that. And by the way, there was a really good Victorian Department of DPI research project done in 2011 that used near sensing to come to a similar conclusion as well. That what you see is that chlorophyll content drop or pause, and then recover slower as well, those stages. So then going back to what you were saying in terms of how that would be useful in being able to adjust yield estimations, absolutely. There's still a fair bit of work to go there. I think there's a fair number of paddocks still to identify and research and look for those correlations, and then be able to, in terms of being able to detect nitrogen at early tillering, be able to say, put this rate on to get this yield. That a similar approach to actually having a look at damage to chlorophyll within the crop, and then being able to estimate the yield on that just needs a lot of data analysis. And the good news is because we've got, in the industry in Australia, we've got yield data now going back years. It's not like we have to wait for the next frost event. We can go back to 2017 and 2018 in the industry, and there's got to be hundreds, if not thousands, of paddocks out there that A, were frosted, and B, were at least partly harvested, not all cut for hay. And so being able to use that yield data and look for the patterns as early as possible to the first frost event will give us a good indication. So if you've got the classic to me, or the classic scenario to me would be a crop that suffered some stem frost, but did okay for the rest of the season, and then looking at the yield variation compared to a year where it wasn't frosted.
There's people out there who've definitely got the data, so it's just a matter of someone doing the work, by the sounds of it, because that'll be, that'll be all great information to sit there and work through, and it sort of adds another layer of information to your decision-making process.
Yeah, and look, I think automatically detecting it is going to be a great objective, and one that I don't think we're far away from. But even now, you can still do some practical things. So I'll show you this example. So this is last year. This was a wheat crop, once again in South Australia. This was the one I mentioned for the trials that we're doing. And what I'm showing everybody here is an NDVI map about 4 days before the frost event. It was the October long weekend last year. And what I'm showing you here is a pretty well-performing crop. All that blue and green is showing really high NDVI values, right, of the sort of like 0.7s and above, which is saying that we've got a lot of biomass, it's looking healthy, it's what you would expect for a crop at that point of the year, at that point of the season. What I'll do now is just switch over to that same crop 6 days after. Now, I've actually got an image of the day of the frost event, which I could pop up here, but it sort of shows you where holes have started being punched into the crop. But this one to me is probably more relevant to the audience, right? Which is what we're seeing here in those sort of darker green areas is certainly a significant change there. So there's hardly any variance at all. Now we look at the whole crop has sort of started going backwards, but there's certainly a part of the paddock that has gone worse than others. Now, I don't think it's going to shock anybody if I said that this area here is the lowest part of the paddock. Not that you can see from the satellite imagery, but up here is a hill that's a wind farm. Down here, the road is at the lowest point, and I don't know if you can see, but from the contours there, it starts to rise again as well. So that's where you're always going to expect frost. The grower had a look at the data, had an argument with the aggro about it, because as you know, cutting for hay is very much an emotive as well as an economic decision. And he decided just to chop 11 hectares along that strip there. To his credit, he's stood up in front of another 30 local growers and said, gee, I wish I'd actually looked at the map, paid attention to the map and chopped that much. Because if we have a look at his yield data, look at the correlation to those damaged areas, to the areas that we're doing as little as 200 kilos a hectare. You'll notice that area is missing from his yield data because that's at 11 hectares that he chopped. So if he cut that instead, also given that for him, hay price was like $300 a tonne at that point, and he has his own hay cutting equipment, it was he would have got a better economic outcome. He had a grain contract to fulfil, so he did have to harvest at least part of it, and he had another 10 or so hectares. It yielded okay.
The NDVI is the NDVI map you've used to get that data there, the middle one, yeah. Is that satellite, drone, or plane? Does it matter? Satellite.
Yeah. Look, at that sort of extent, yeah. And look, because, as most people know, frost, particularly damaging frost, typically happens around a series of clear nights. It's cold but clear. We're usually able to get satellite imagery near enough to be able to, or close enough to the event to be able to make an estimation.
How soon after the event? Like you obviously said you had one in the day or so after it.
Yep.
Is it 3 days, 4 days, 5 days, or 6 days after the event that you take the satellite image to be confident that you've got it right?
Well, so far, if we've got a satellite image between 4 and 7 days, I'd even say 4 and 14 days, we see the extent. Obviously, the earlier the better to be able to make a decision. Because it's often if you're going to cut, you want to cut early to get the best possible price. Definitely from that sort of like 5 day period, it's pretty much settled. You're not, if I showed you, I can't really show you the next one because he harvested it straight afterwards or cut it straight afterwards. But at that point, you can it's pretty much the extent of that frost damage is set in. It doesn't grow any more than that. And you can see that with the yield map as well.
I'm imagining the amount of time you can save as a consultant not having to be in all those paddocks. Like just going, we'll wait 4 days and I'll get the data come in and then I'll start going out there and I'll ground truth. And you don't have to go and ground truth 20% of the paddocks, whereas you had to go and check every acre of every paddock. It's a massive time saving.
And even if you focus areas, look, the grower in this case did his own scouting, and he was saying, look, he would look at so obviously he focused on the area that he knew always gets frosted, that lower area near the road, and he'd go to one sort of clump, one set of heads, and he'd squeeze them, and they'd be obviously frosted. He'd walk 2 metres away and try another clump, and they'd look fine. And how do you make a cut decision based on that? Which particular sample is he taking is representative of that hectare, or even in that case, that square couple of metres. So at least this gives him a much more accurate understanding of the overall extent and allows him to make that cutting decision a lot more accurately.
I think I saw some stuff on Twitter last year where one A-grade was having a bit of a go at another consultant, and they basically said, got the farmer's crop, and this farmer's been told to cut his crop, and they stuck it in a bucket full of water that had dye in it. So the dye came out through all the leaves, and he's just going, and it all went to the tip and out to the head and everywhere else. I've never seen it done before. It was fascinating, and basically said, this guy's been told to cut his crop, and yet his crop's fine. And so getting an accurate decision is hard. And like you say, it's such an emotive thing. If you had a data layer that could just take some of that guesswork out of it or just refine the process, be well worthwhile.
Yeah, absolutely. And look, the ROI in this particular case is, if you're, $300 a tonne for hay is probably, not going to happen every year, I'd hate to say. So even if you went back to more realistic prices, if, in Marty's particular case, if instead of just cutting that 11 hectares, he'd cut another 11 hectares, I mean, the return to him based on even $100, right, of being able to reap, 3 tonne of hay, or I should say, 3 tonne of hay versus sort of like less than half a tonne of grain, means that he was making 300, could have made $300. He was actually making $900 instead of $75 at typical sort of grain prices, but also not overcutting, because that's the other thing. You'll get some growers that just go, forget it, the season's stuffed, I'm just going to cut my losses, when, they could actually sort of save, half the paddock by not cutting it, and then still, at normal grain prices, if it still yielded 2 tonne of grain out of those sort of unaffected areas, that certainly is going to be making sort of $500 instead of $300.
And a lot easier to do grain than hay. So,
Yeah, absolutely. And we are talking gross margins here.
Yep.
But that's also another factor is also knowing when to cut, but also when not to cut, where not to cut. A couple other use cases I just wanted to point out here. What I'm showing you here is look, I think it was barley, but this is irrelevant because this was the fallow period. What we're looking at here on the left-hand side is an MS AVI map during the fallow period in mid-January. And then on the right-hand side, we're looking at NDVI map of a couple of weeks later. And so there's not that much difference there. This is where NDVI doesn't really show you too much of that period because of that noise that you get from the soil. But if you have a look at the MSAVI map of the same date of this one, in early February, what we've identified there is a fairly significant weed outbreak. Unfortunately, the grower didn't treat it, and it was reflected in the yield data as well. So we saw a very similar correlation on the yield file with those areas where the weeds came in and sucked all the available nitrogen away, and probably some.
What sort of weeds, James? James, what sort of weeds?
I can't remember. I was about to say ryegrass, but it wasn't. It was something else.
Is there any difference in trying to understand whether it's a grass weed versus a broadleaf weed, or is it just ground coverage is that much more that?
Yeah. At this point, it's vegetation where there shouldn't be vegetation. It could have been volunteer wheat, for example, still wheat at that point.
Yeah, exactly.
Another example of a customer of ours where this was actually rye, wild rye, or ryegrass, sorry, and that was untreated probably until it was a bit late as well. But in this case, quite early in the season, the MSAVI is showing us this sort of deep pink area. And can you see, if you can see that circle or that shape around it, that's the fluorescence anomaly detection engine picking that up and alerting the agronomist that there's a problem there. Here's the same region about 8 weeks later, and you can still see, even though the crops come up now, I mean, we're talking that was sort of mid-May, well, I think this is early July. What you can see is still that even though the crops come up, this area of untreated weed is performing a lot lower than the rest and still coming up as an anomaly. Slightly different shape, right? But you can still see that area. Right? So when they finally went out there based on that and did some scouting, they realised they had a fairly serious infestation. This one's actually only from a few weeks ago, 5 weeks ago, 6 weeks ago. And so what we're looking at here is a wheat crop that we also detected 4 anomalies here. There is a bit of a soil type variation there, but these anomalies had already taken that into consideration. And when scouted, they realised they had lucerne flea infestation. So what we're seeing there is that even that early in the stage of this crop, we're seeing areas that are performing less than what they should be, particularly in comparison with the rest of the crop. And that's the areas that you should be focusing on scouting rather than, this is, I think, a 100 hectare paddock. Rather than trying to drive the entire paddock, go and have a look at those areas where there's a problem.
Awesome tool.
And so, look, this is probably where I'd say the feedback that I've had from growers and agronomists is that what they want to do is less time looking at maps and analysing and trying to make sense, and have more time just being alerted that it's a problem. If you're an agronomist and you've got sort of 20 growers that you're doing work for, and that's probably a bit of an extreme, but that could mean that you've got hundreds and hundreds of paddocks. Nobody has the time to go through and have a look at every single paddock and sort of look if there's something wrong. So what they are looking for us to do is do a lot of that work for them. So, the first time they'll sign up for fluorescence, they'll tend to have a bit of a look just so that they can trust the data, that they're seeing things that they know about. And then they expect us in the background that every time a new satellite image comes in is to analyse it and send them an alert if we see an anomaly. And they can either forward that to the grower, or if it's a grower, they can go and scout it themselves and confirm what it is. We encourage them to then label what they see, because the more of that we get, we're building up a database of tying anomalies to the cause of the anomalies. Eventually, we'll be able to match that. We'll be able to say, we suspect, maybe initially we suspect that to be a pest, not a weed, right? Because we've got enough of these anomalies confirmed by ground truthing to say, here's what it looks like when it's typically pest infestation. that sort of 20-year time frame, or I even think, Tim, this 10-year time frame, we'll be able to get to the point where we've got enough pattern matching to be able to go, look, that's more likely Leucinfluke, right? Versus something else. But, early days now, the payback is already immediate to be able to say, 100-hectare paddock like that, here are the areas, and really early in the piece, being able to go in and identify the problem and treat the problem before it makes even more of an impact on you.
Oh, it's just being able to know where to go. That was always the biggest problem. Especially bigger farms, like you've got a 400-hectare paddock, 500-600-hectare paddock, and you can't check every acre of it, and so you're always just sort of hoping you're going to the right spots, using a bit of gut feel to hope you're in the right areas to check the right things. And if something was going wrong, often you would miss it because you physically can't be across everything. So
yeah, absolutely. And look, what people are doing now is that they're running this on their iPad, going into the paddock, clicking on that little pin function, which will locate them around the anomaly. Particularly for these bigger paddocks, you can kind of get a bit of a lie of land and get an idea of where you are, but it becomes more precise, and they can drive themselves right into the middle of that and start checking it from there. So it's not just about being in the paddock, it's also about which paddocks. If you've got hundreds of paddocks to look at, or make a decision about which of your 100 paddocks you need to look at today, what you identify are which ones are actually getting a drop in performance, or which ones are actually not getting the increase in performance that you're looking at. So let's have a look at this particular paddock today, because everything else looks okay, but this one is the one that looks like there's a drop in the NDVI across the entire paddock. That may mean that either the whole paddock has got a problem, or one area in the paddock has got enough of a problem that's dragging the average down to the whole paddock. And so then if you look at the individual paddock, obviously here you're seeing there's a problem in this particular area. And that's not soil type, even though it kind of looks like you'd expect that to be soil type. That particular anomaly wasn't there 2 weeks previously. So, any questions at this point, aside from the ones we've already discussed?
If anybody's got any questions, they can just put it in the chat box there, and I'll ask them of James. So, more than welcome to fire away. Are there any other uses for the technology, like other agri industries, James, that you're looking into, or we've covered a fair bit of broadacre here, but other things you can sense in other industries?
Yeah. So look, thanks, Tim. Let's start with irrigated crops. So I'll go straight into horticulture. So for orchards with permanent irrigation, being able to detect blockages and leaks. It's pretty useful because if you get a leak, what you typically see is an increase in NDVI and NDRE, not just from the trees themselves, but from the weeds that you get around that. And if you get blockages, you typically see a drop in NDVI as well, and NDRE. So if you've got subsoil or lateral problems, even satellite is enough to pick that up. We've also developed a model where if you fly a drone over the paddock over the orchard, I should say, we can actually detect individual trees, and then we can use that detection to model out any of the weed effect as well, so that when we're looking at measuring biomass or looking at measuring health, particularly during a flowering period, we're sort of disregarding, just like we disregard soil in MSAVI, we're disregarding ground cover and just focusing on what's on the actual trees at that time as well.
So do you need to go back and do drones for that, James, or is it?
Yeah, just the first time. Yeah. Particularly for non-deciduous or mostly evergreen crops, like say olives, for example. You just need to fly the drone once to get the data. Once we've identified the trees, we've got an understanding. We were able to then calibrate that if the bulb grows or shrinks or whatever. We're able to model that as well.
And are you doing any work with research companies or people looking to generate data for people in ag, so to sort of verify results or get early season results for weed trials or fungicide trials or anything like that?
Yeah, look, we work usually in partnership with agronomy firms for some of the different DPIs and RDCs as well, sometimes directly with them as well. So sort of numerous trials we've done. Cotton's probably a good example where we've worked with DPI New South Wales using our remote sensing to detect both the incidence of vert in cotton and also the effects of various treatments that they're trying as well. We're doing some work on measuring plant available water in a crop as well. So I'd say it's probably just continuous. There's always some sort of research grant that we're working on, and typically what we're bringing to it is whatever's trying to be determined. We're using the multispectral, in some cases hyperspectral, which is even that's a bit like TV versus HD TV. Gives us more bands. Be able to detect the incidence or response as early as possible and be able to quantify it more accurately than doing field testing.
Beautiful. And for a consultant or a farmer, how much does it cost to what's the service like? How much do you charge to fly the paddocks, or satellite image the paddocks and serve up the data every week, or how often you do it?
Yeah, absolutely. Look, as a kind of guideline for satellite imagery for a season, you're looking at around about $2.50 a hectare. And the reason I say roundabout is that we actually charge per farm. But if I kind of average it out, it's typically that's just to understand that. And the reason I sort of go as per hectare price is that that's for satellite imagery. If you were to get fixed wing aircraft over, you're probably looking at about another $2.50 per hectare. And that's not necessarily our price. That's usually just from the contractor, just to give you an idea. We ingest that information for free. If you get it to us, we'll do it, or we can do it on your behalf. And then drone, about another sort of 50 as well a hectare, or sometimes a little bit higher, depending on your drone operator. And it's we can certainly arrange it for you. But typically nowadays, a lot of growers and a lot of agros know their own contractors, and all we do is provide them with a document cable. As long as you produce it to this particular set of specifications, we can import it straight away and use it.
So when we're talking about the satellite data, is that $2.50 a pass or $2.50 for a season, or how does that work?
For a season.
For a season. And how often are they flying?
Yep, yeah, good question. So in most of the growing parts of Australia, it's I'll say average 5 days. It's anywhere between every 3 and 8 days, depending where you're out there. So that's where you get the average. Obviously, cloud cover is something that impacts on that. We'll remove that from analysis if there's too much cloud. It's obscuring it, because you're not going to get much value out of that as well. And that's where we say that if you've got prolonged periods of cloud cover, it's not a bad idea to get a plane up or a drone up if you need to make a nitrogen or some other sort of application decision at that point as well.
We've just got a quick question here. Do you have any area maximums and minimums for the service? Like, is there a minimum area or maximum area that you'll cover?
No, because it's satellite. I mean, if you had somebody farming the whole globe, we could potentially do that as well.
And then out of that, like obviously, so you've got the data platform. Is there a license fee for the Fluorosense data platform to crunch the data and give you back the maps or anything else like that?
No, that is the charge. So what you get for that per season is the maps and the data analysis for the entire season.
It's a pretty handy price for a very good service.
Thanks, that's what I think as well.
Yeah. You could almost charge more for it, but I won't say that because I'll get myself in trouble. But no, that's excellent.
Yeah. Oh, look. I mean, everybody will sort of tout their own prices, but look, we understand it's still a new technology. We understand that to make this useful, we also have to make it financially achievable as well, allowing putting it at the price point, and also it's a combination of getting the right price point and the right usability, so that it can make a big difference as well.
Beautiful. Are there any other questions for James? Because if not, is there anything else you want to cover, James, before we wrap this up?
Thanks, Tim. The only thing I'd say is, look, if anybody's interested in having a look, we've got 30-day trials. All you have to do is go to fluorosense.com. You don't just have to monitor the current season. You can go back a couple of seasons as well. Sometimes that's not a bad idea, because if you know that you had a particular issue, why not go back and have a look at how we would have tracked it if it was happening in real time?
Yep, awesome. No, it's great. It's really exciting technology, and I really mean it. It's great to see, some of this stuff actually becoming useful. I played around with a lot of this stuff in the early days of precision agriculture, and found it challenging to get it to live up to the hype of what we were trying to do. And it's good to see we're finally starting to get to a stage where some of these things are becoming achievable. It's great to see what you guys are doing, James, and really want to thank you for your time today, and thank people for coming along and listening. And it's been great, and thanks very much.
Thanks, Tim. Look, thanks for the opportunity. Thanks for the good questions as well, and thanks for everybody for your attention. I hope you learned something and found it interesting.
Excellent, guys. Thanks very much. And just let everybody know, well, number one, thanks for coming along today, and remind you we've got our next meeting on the 19th of July with Ben Van Gelden from KPMG, which looks like being a great one as well. Thanks so much to James today, and everybody have a great day. Thank you.
Thanks, everybody.